Right, question 14, where you're being asked here to find the pH of a 2.05 molar solution of HA. You're told what the Ka is here as well, 1.61 times 10 to the negative 5. Now, usually on a test question, I'm going to go ahead and show you how you'd set this up. And this is going to pretty much follow the test question, at least in part. But if it's going to split up into solution, it'll be HA gives H plus A minus. We can set up a table here. Initial molarity 2.05, 0 and 0. Then we've got the equilibrium, which is going to be 2.05 minus Z, and Z, and Z. And the Ka value then will equal H plus times A minus over HA, which is going to equal Z squared over 2.05 minus Z. Now, because this is a weak acid, and I know that because the Ka is less than 10 to the negative 4, so I think it's worth a shot at assuming that this is a weak acid. And if it's a weak acid, what that means is we make this assumption. We assume that 2.05 minus Z is going to approximate out to 2.05. I'm going to point you to my other videos that discuss this kind of question so that you can get a greater understanding of why we make that assumption. Now, it does help with our math here. So what I can say now is that the Ka value, which is 1.61 times 10 to the negative 5, equals Z squared over 2.05. So as you can see, we wouldn't be left with a quadratic equation to solve in this instance. I can now solve for Z. The way I do that is I take the 1.61 times 10 to the negative 5, multiply it by 2.05, and then take the square root of that result, and I end up getting 0.00574 as my value for Z. Now Z happens to equal the concentration of H plus. And I know that because there it is there. If that's the concentration of H plus, then I can find the pH. The pH is going to be the negative log of the hydrogen ion concentration, which means it's going to be the negative log of 0.0574, and this is going to come out to be 2.241. Now, when I'm doing the negative log of something, or the log of something, the number of decimal places will be the same as the number of significant figures in whatever we took the log of. So this has 3 sig figs, so this is going to be 3 places past the decimal in the pH. And if we were doing this properly, or we're doing it in an actual test, we would validate the assumption that we made down here about assuming that 2.05 minus Z is approximately 2.05. Now, the way I do that is I take my Z value and I divide it by my original concentration to see if it's going to be more or less than 5%. So I do 0.00574 divided by 2.05 times 100%, and that actually comes out to be 0.28%, which is less than 5%. So my assumption here would have been valid.